Get ready for a cosmic crash course. Jupiter's the biggest planet in our solar system, a massive gas giant that leaves scientists guessing about its layers, density, and mysterious core. We can only imagine what lies beneath those stormy clouds. But today, buckle up as we embark on an out-of-this-world simulation, literally launching a needle at light speed towards Jupiter. Will it pop like a balloon, or will the planet's crushing pressure send it on an epic journey to the core? Let's dive in and find out. The possibilities are endless. Will our speedy needle create a mini black hole within Jupiter, or will it escape the solar system altogether? The collision itself is key to unlocking the secrets of this gas giant's hidden world. But here's the twist. Even traveling at light speed, our needle isn't likely to just sail right through like an airplane gliding through Earth's clouds. It turns out Jupiter's not as smooth sailing as it seems. Buckle up. If we hypothetically shoot a needle at light speed into Jupiter, it'd zoom from its surface to the core in an astonishing less than half a second. As it makes its way down, it might even pass through a solid core, and here's where things get really cool. Scientists believe this core could be made of something called metallic hydrogen. Now, you might wonder what that is. Well, in 2017, Harvard University researchers Isaac Silvera and Ranga Diaz managed to create metallic hydrogen in their lab by squeezing it with an incredible force of 500 gigapascals. That's a whopping 5 million times our Earth's atmospheric pressure. Though this substance only lasted for a few seconds before disappearing, they believe there should be heaps of it hiding at Jupiter's core due to its extreme conditions. Now that we've got our metallic hydrogen core nailed down, let's talk about what would happen if our speedy needle actually reached it. Imagine the explosive chain reaction, right? Not quite. The reason is staggering. There's an astronomical difference in weight between our tiny 0.2-gram needle and Jupiter itself, which tips the scales at a mind-boggling octillion kilograms. To put that into perspective, we're looking at a disparity as huge as the one between a human and a single bacterium. Let's put things into perspective. Jupiter's had its fair share of close calls. In 1984, it took on comet Shoemaker-Levy 9 head-on and came out unscathed, swallowing those fragments whole before they even reached its core. But back to our speedy needle, here's the twist. Speed isn't going to be what saves it. In fact, hitting the speed of light would turn that 0.2-gram needle into a nearly infinite energy source, according to Einstein's theory of relativity. And when this happens, the first atom it encounters in Jupiter's atmosphere won't just be nudged, it'll be obliterated by an immense power blast that our poor needle has become. So you're thinking, whoosh, with that needle's energy blast, we'll blow away Jupiter's gas layer and finally see the core. Not quite. What we'd actually be left with is metallic hydrogen, which would evaporate just like our lab samples here on Earth. It's as if all that dramatic energy release would lead us right back to square one with nothing new to learn. So, how can we create a more effective experiment? Imagine if our ultra-strong needle could zoom toward Jupiter's center at light speed, we'd be on the cusp of unraveling its secrets. But first, this unbreakable tool would have to withstand some serious obstacles. Slicing through ammonia clouds and diving into a stormy zone where winds are a blistering 120 meters per second. NASA's Galileo spacecraft learned the hard way in 2003 that Jupiter can be brutal. It disintegrated before even reaching this point, but our indestructible needle won't falter, continuing its journey to a depth of 250 kilometers, where liquid hydrogen and helium mix in a swirling blend. As it plunges deeper, keep in mind that while the needle itself won't heat up from friction, it's guaranteed to kick-start some serious atmospheric heating around it. Hold up. We're not quite ready for liftoff just yet. Think about it. Hydrogen's so reactive that a single spark could trigger an explosion. With our indestructible needle blazing its trail, it might inadvertently set off a chain reaction, potentially incinerating Jupiter itself. But before you start worrying about a galactic inferno, take a deep breath. There's one crucial ingredient missing from Jupiter's explosive mix: oxygen. You won't find any up in the gas giant's layers, so our hypothetical apocalypse is put on hold. However, lightning does strike in the upper atmosphere of Jupiter, and that could be our needle's downfall. A metal probe like ours would attract those electrical surges with catastrophic force. No matter how indestructible it seems, a single discharge could knock it off course. So, it looks like getting to the center of this gas giant just isn't in the cards. But wait, there's more. Jupiter's magnetic field is so intense that it doesn't just stop at the atmosphere. It extends all the way into space, a whopping 7 million kilometers towards the Sun and up to 650 million kilometers towards Saturn. Now imagine our needle zooming through space at the speed of light. It'll be like being in a strong current. Those magnetic field lines will wrap around it, throwing off its trajectory and effectively turning our probe into Jupiter's tiny satellite. And if that weren't enough, even at light speed, our needle would only complete one orbit around Jupiter in just a few seconds. But how can we overcome this magnetic mayhem and get back on track to the gas giant's center? One solution could be to ditch metal altogether for the indestructible probe. We might consider using refractory ceramics, the same kind of material used to build space shuttle hulls. By making our needle from these super strong, heat-resistant materials, we just might be able to outsmart Jupiter's magnetic field and make it back to its core. Now, let's think about how we can best utilize this lighter ceramic needle. Since it'll be 3 times lighter than its metal counterpart, we should launch it into one of Jupiter's calmer regions, the areas where atmospheric currents are minimal. The Great Red Spot immediately comes to mind. Who wouldn't want to aim for the eye of a storm that's been raging for centuries? It's like finding calm in the middle of chaos. But here's the catch: the center of the Great Red Spot is actually way off from Jupiter's core. We'd be better off aiming for one of its poles, right? Not so fast. Those poles are also anything but calm, with turbulent whirlwinds and thunderstorms that would make any astronaut want to stay far away. Here's the rewritten paragraph, but here's the twist. Our ceramic needle actually needs an entirely different kind of launch pad. And surprisingly, it's right along the entire equator of Jupiter, where things would be just perfect. Once launched, this super strong needle will slice past the chaotic whirlwinds and lightning in the upper atmosphere like a hot knife through butter, because it'll be traveling at incredible speeds, almost as fast as light. As it dives deep into Jupiter's interior, thousands of kilometers down, it'll encounter an ocean of liquid metallic hydrogen that's mind-bogglingly hot. Think temperatures ranging from a scorching 6 degrees Celsius all the way up to a blistering 20,000 degrees Celsius. The friction generated by this journey will be so extreme that our needle won't just slow down, but it'll actually get stuck in the solid core of Jupiter. And the impact, it's nothing short of astronomical. The massive disturbance caused by the needle's passage at such incredible speeds will mix up Jupiter's layers like you'd mix milk into your morning coffee. The result, a truly cosmic shake-up. Here's the rewritten paragraph now. You might be wondering what happens to our indestructible ceramic needle after it disappears into Jupiter's depths. And the truth is, we'll never see it again. But here's the amazing part. The aftermath of this experiment will be so dramatic that it'll be hard to ignore. Gigantic storms on Jupiter's surface will erupt, making it impossible to miss the impact our needle has had. And what does it prove? The solid core of Jupiter, a fact that's still shrouded in mystery for scientists. But if we're wrong about this, and Jupiter actually has a liquid core instead, well, the consequences would be nothing short of catastrophic. Believe it or not, just one tiny needle launched at nearly light speed could potentially destroy the entire gas giant. The science is still uncharted territory. They admit that even today, there's no definitive answer to whether Jupiter's core is solid or liquid. And if it's the latter, a shockwave from our speedy needle could destabilize all of Jupiter's inner layers in an instant, unleashing chaos on a truly astronomical scale. Here's the rewritten paragraph. This experiment could get seriously out of hand. If our needle hits a liquid core instead of a solid one, Jupiter's shape would start to morph unpredictably, and its gravitational field would go haywire. Imagine all the moons suddenly finding themselves flung out of orbit. It's a mind-boggling thought. But that's not even the craziest part. A light-speed needle slamming into liquid hydrogen could create an intense compression zone, sparking a nuclear reaction right in Jupiter's heart. It'd be like witnessing a mini version of our sun's core. But instead of steady burning, it would be a flash of incredible power, and for a few moments we'd have not one, but 2 suns blazing in the sky. However, this spectacle wouldn't come without a terrible cost for Jupiter, with no solid core to anchor its gravity. The planet might actually implode under the pressure of that nuclear explosion, leaving us stunned observers to wonder what just happened. Here's the rewritten paragraph. This cosmic collision could trigger a chain reaction like nothing we've ever seen. Jupiter would likely disintegrate into a massive gas cloud that spread throughout the solar system, wreaking havoc on everything in its path. The implications are dire. With thousands of asteroids in tow, Jupiter's sudden vanishing act would send these space rocks careening towards all the planets, including our home Earth. It's a recipe for disaster, as these asteroids could crash into us, causing untold damage and destruction. And that's not all. Without Jupiter's massive gravitational pull to keep things in check, the inner planets like Earth would be thrown into a state of chaos. Their orbits would shrink dramatically, leading to scorching temperatures that make our planet uninhabitable. So buckle up. The results of this thought experiment are about to blow your mind. Here's the rewritten paragraph now. Here's where things get really interesting and a bit mind-blowing. If we were to launch a needle at Jupiter traveling at light speed, it could potentially rip apart its mysterious layers, helping us finally understand what makes this gas giant tick. It'd be a groundbreaking discovery, either confirming or debunking one of the theories about Jupiter's inner workings. But here's the catch: there's a 50-50 chance that this daring experiment would go catastrophically